Okay.
You can proceed, sir.
Sorry.
You can proceed further, sir.
I will proceed for further next topic.
Yes, sir.
Okay, fine. Thank you. Okay. So just now we have seen that what is actually the multivibrator and different types of multivibrators. So for our syllabus, we have a multivibrator using 555 IC. Okay. Basically, previously amplifier we have seen. This amplifier is IC 741. 741 is a operational op-amp IC. Now, this multivibrator to produce these types of waveforms, that is done by using 555 IC. 555 IC is also called as timer IC. 555 IC is also called as timer IC. That is what I told, that the multivibrators are also used in a counter circuits or timer circuits. So this 555 timer IC is used to generate a monostable and astable multivibrators. Bistable is not there. We will see just monostable and astable here. Basically, what is this IC? This IC is useful to generate accurate time delays. The 555 IC is used to generate a time delays from millisecond to hours, and also it is used for oscillation purposes. Okay. So first we'll go for astable multivibrator. As I told, astable is nothing but what? Continuously there is a switching between the low pulse to high pulse and high to low. So continuously it is switching between these two states. That is called as astable or free running multivibrator. So this is the block diagram. Astable multivibrator, this is the block diagram by using a 555 timer IC. Okay, so here it is having it is a 8-pin IC. 555 timer is a 8-pin IC. So here pin, some configuration is there. Pin 1 is a ground. Pin 2 is given to this capacitor. Pin 6 also connected to the capacitor. Then pin 7 is in between the RA and RB. Then pin 4 and pin 8 are directly connected to VCC, whereas pin 3 is V out, output voltage or output port, that we will get output side, where we are going to get a continuous free running clock cycles. Now here I will get continuous free running clock pulses. Now there is a second figure also, which is same as the above one. The above one is a direct pin connection. This one is internal connection of this 555 IC. Okay, so what is there inside the 555 IC? Within this 555 IC, there are two operational amplifiers and one SR flip-flop and one transistor. Okay, two comparators, we call them as comparators, and this is a flip-flop, SR flip-flop, and then this is a transistor. These are used, and rest of the thing is same connection of this above block diagram. Okay, so why basically we call it as a triple five timer? That is why, uh, because here we have three 5 kilo ohm resistors which are creating a divider, voltage divider network. 5k here also one 5k is there, here also one 5k is there, and one more 5k is there. So these uh, three 5 kilo ohm resistors are there. Give me a second. Drivers ಇಲ್ಲ. Okay. Uh, so this is actually inside this triple five timer. Pin 7, pin 6, pin 2 is there, no? So when it is being connected like this, here 5 kilo ohm resistor, 5 kilo ohm resistor, and another 5 kilo ohm. Three 5 kilo ohm resistors are connected to create a voltage dividing bias between this comparator 1 and comparator 2. There are two comparators. Okay, this is one comparator, another one comparator. Comparator 1 and 2. And there is a flip flop, and also there is one transistor. So this circuit, how this circuit is going to generate a square wave. See, here we have got a square wave output waveform, and this is a capacitor waveform. That is, this capacitor is going to charge and discharge, charge and discharge. Okay, these are the levels. Now, how this circuit is going to work? I'll explain. Now, what will happen? The VCC is being connected to the pin number 6 here directly to the ground through pin 1. Okay, in between this 5 kilo ohm resistance, another 5 kilo ohm, another 5 kilo ohm divided by 3. Okay, if you go for comparator 1, what will be the voltage divider formula for this comparator? It is, there are two resistors are there, 5 kilo ohm, 5 kilo ohm. That is why 2 divided by 3. Total how many 5 kilo ohm? 3. Okay, into what is the input voltage? VCC. Okay. Now the comparator 1 will be producing how much voltage? 2 by 3 of VCC. The comparator 2, how much this is going to generate the voltage by taking this VCC? It is directly VCC by 3, because only one resistance is there at the output side, right? So the comparator 1 is going to generate 2 by 3 VCC. Comparator 2 is going to generate VCC by 3. Are you understanding?
Yes, sir.
Okay. So now,
Yes, sir.
okay, after this, the same VCC pin is connected to this capacitor. So the capacitor is now going to charge and discharge, is going to charge for this VCC through RA and RB, and then it is going to discharge through pin number 7 and transistor towards the ground. The capacitor is charging from, what is the source? VCC, and the capacitor is then discharging through pin number 7 and a transistor, because now it is here, it is connected to ground. So whenever the transistor is turned on, the capacitor starts discharging. If the transistor is off, the capacitor start charging. Now let us consider, in the beginning, the value of Q. SR flip flop, I think you know, how SR flip flop is going to work. Okay, S is set, R is reset. Okay, so now first consider the value of Q is 0, and the value of Q bar, now it is going to be 1. Okay, now what is the waveform that I'm going to get here? High, correct? I will get high. Then why it is high now here? Q bar is 1. Okay, if Q bar is 1, then Q is always 0. This is 0, Q bar is 1. So output side I am getting 1. As because this is 0, the transistor is off, the base of the transistor is not getting anything from this Q. Okay, so transistor is off. Because the transistor is off, the capacitor will not discharge, but instead what will happen? There is a VCC which is supplying the current to the capacitor. So instead of discharging, capacitor now starts charging. Okay, and then the same voltage is being given to comparator 1 and comparator 2. Now how much voltage? The capacitor has now been fully charged, then it will not charge again. Then this comparator 1 is going to generate 2 by 3 of VCC, and then this comparator 2 is generating how much? VCC by 3. Okay, now this VCC first given to this first comparator, it is being divided here. Okay, it is being divided here. So until the capacitor value reaches to this 2 by 3 value, this comparator 1 is not going to give any result to the any value to the yes, that is set of the flip flop. So once this comparator reaches the voltage of 2 by 3 VCC, then this comparator is going to give the input to the yes. So now yes will become 1. If yes is 1, the output of flip flop is now going to be 1. Okay, so if Q is 1, then Q bar is 0.
0.
So previously Q bar was 1, now it has become 0. And as Q is 1, the transistor now turns on. So now what will happen? The capacitor has already been charged now. Then whatever the charge storage current is there, that starts discharging through this transistor. Then what will happen? This voltage of this capacitor starts falling. So whenever that reaches, the capacitor value reaches below this VCC, because this VCC, this comparator 2 is generating VCC by 3. Okay, so when this capacitor reaches this value VCC by 3, then comparator 2 will operate and it will give a high value to the reset. So if it is been reset, then what will happen? Q will become 0, Q bar will become 1. So until that it was 0, now it will become 1. Output becomes Q bar becomes 1 and Q becomes 0, and this transistor turns off. Now what will happen again? The capacitor starts charging. So this charging and discharging of the capacitor has been shown up here, and the output of this SR flip-flop is going to be high to low and low to high. Continuously it starts running. So this is how we are configuring this 555 IC to generate a clock wave signal, clock pulse, or we can also call it as square wave signal, as it is having a fixed waveform, fixed time duration between each clock cycles. Is that okay?
Yes, sir.
Okay. So this is Astable Multivibrator. So the explanation is also there. I'll just forward this file to the group. You can once again read it from these notes and you can tackle your examinations. Then monostable multivibrator. So what we have discussed about monostable, it is a one-shot multivibrator, correct? It is a one-shot multivibrator. Nothing has been changed here except pin number 2. You can see the pin number 2 in this Astable. Where it is been connected? It is connected to the capacitor. Okay, so because why the capacitor starts charging and it starts discharging, that is why it is to monitor that capacitor, the pin number 2 of this comparator is been connected to the capacitor here. But now here the pin number 2 is not connected to the capacitor. It is just connected to the plus VCC triggering input. Okay, so we told that a monostable multivibrator is a one-shot multivibrator. So once if you give input from the external, then it will go high, and after some time again it will come back to its original position 0. Like waveforms, okay, waveforms are not there. I'll just draw it. Except remaining everything is same here. So here what will happen? Same thing. This comparator 2 by 3, and this comparator VCC by 3. So once set, we will get a high value and continuously a low value, and that is being done based upon this trigger. If I trigger, what will happen? This comparator will check, will compare the voltage between the VCC, that is VCC by 3, and this triggered input. So what will happen? It will reset the SR flip flop. If it is been reset, that means what? This becomes 0 and this Q bar becomes 1. So if it is been 1, suddenly what will happen? This the 0 level goes to high, remains high only until what? Until this transistor becomes 1. Then it goes 0 and continuously it flows 0 only. Why? Because it is not comparing continuously. The comparator 2 is not comparing the value between the VCC and the trigger input. It compares only when we give trigger input. That is why we get only one pulse, and that too whenever we trigger, we give input through this trigger pin number 2. Is that okay?
Yes, sir.
Yes, sir.
Okay. So I think the class session is also near to end. Okay. So these are regarding astable multivibrator and monostable multivibrator. Fine. We'll continue in the next class.